You are welcome. In this class, we're going to be looking at problems of motion under gravity. That means when an object is thrown up or released from a height. So we're going to see the uniqueness of such motion problems. Let's start from number 1. A ball is thrown from a height of 20 meters. How long does it take to reach the ground? Okay, one thing you need to note is that when something is dropped from a height, so we assume that it is released from rest. So the implication is that the initial velocity is equal to 0. Okay, so then the height, which is the distance, is equal to 20 meters. How long does it take to reach the ground? So we're being asked the time, and we have that acceleration is equal to 9.8. Okay, it's the same thing as acceleration due to gravity. All right, so from the variables given to us, which one is absent? Okay, we don't have the final velocity. So we're going to choose the equation that does not have the final velocity. And the only equation like that is S is equal to ut plus half at square. Okay, so that means that S, which is 20, so we now have 20 is equal to u is 0. So if you say 0 multiplied, so this one becomes 0 already, plus half. What is our A? Our A is 9.8 acceleration. Then T is what we're looking for, multiplied by T square. Okay, so that means that 20 is equal to, this cancels this, it gives us 4.9. So 4.9 times T, so we have 4.9 T square. It implies that, so if we make T square the subject, it's going to be equal to 20 divided by 4.9. Okay, so that would be T squared will be equal to 20 divided by 4.9. What would that give us? That will give us approximately 4.08. The implication is that T will be equal to, so for we to remove the square here, it means that this becomes square root of 4.08. Is that clear? So it means that T square root of 4.08 is going to be 2.02, and this is in seconds. So that is our answer. All right, let's take the second question. The second question says, a stone is thrown upward with a speed of 15 meters per second. How high does it go? A stone is thrown up. So this is the floor. and the stone was thrown up. Each time a stone is thrown up at maximum height, you need to note that v, final velocity, is 0. Because when you throw it up, when you get to maximum height, it will be in a position. There's no motion before they start coming down. So at maximum height, the final velocity is 0. Alright. But the initial velocity of throwing it up is what? 15 meters per second. Then we're asked, how high does it go? What is the distance? How high from here to here? What is the distance? Okay, so that is what we're being asked. And we know that acceleration. So when something is thrown up, it is going against gravity. Anytime something is thrown up, it's going against gravity. So we are saying that acceleration will be equal to negative acceleration due to gravity, showing that it is thrown up, it is going against gravity. Okay, so if we look at the variables that we have, which of the 5 variables, which one is not here? There's no time here. There's no time here. Time is not mentioned here. So we choose the equation that does not have time. And the only equation that does not have time is v squared is equal to u squared plus 2as. So what it means is that v is 0, then also is equal to u is what? 15. So we have 15 square plus 2 multiplying acceleration. So it's going to be minus this. So it's going to be minus 9.8 because a is equal to negative this. Then multiply by the distance that we are looking for. Is that okay? So this will now be 0 is equal to 15 square is 225. 2 times this is going to be minus 19.6 multiplied by the distance. So if we were to make s the subject of the formula, so this will move to this side. And if it moves to that side, it means that what we now have is minus. No, it's not going to be minus again. If we move to the equality sign, the other side of the equation is going to be 19.6 s is equal to 225. It means then that s, which is the distance, is equal to 225 divided by 19.6. So this is going to be approximately 11.48 meters. Because this is distance. Okay, take note of that. So let's take the next one. This question says, a ball is thrown vertically upward and returns to the thrower's hand after 6 seconds. What was the initial velocity? So the ball now returned back after 6 seconds. Okay, so when a ball is thrown up, returns to it. So remember, when a ball is thrown up at maximum height, remember at maximum height, it will get to maximum height then before. At maximum height, the final velocity is always what? 0. Because it comes to rest before coming down. Okay. So at maximum height, it is what? 0. So the time it took for it to move to the maximum height and come down is 6. So if this is the time it took to move up and come down is 6, then it means that the time to move to the maximum height will be what? 3 seconds. Why is it so? Because the time it took to get to maximum height is the time it will take the same time to return back to position, return back to the position where it was thrown. So from the person's hand, so it took 3 seconds from his hand to get to maximum height and took another 3 seconds to return. So that's why it is 6. So the time for it to get to maximum height is what? 3, which is half of that time. And that is what is our time. You get that? Okay. Then we're asked, what was the initial velocity? So we are being asked the initial velocity. We don't know the initial velocity. Then we have our acceleration. So when it is thrown up, it is acting against gravity. So our A is going to be minus G. Is that okay? All right. So from the parameters we have, which one is not given? We have V, have U, have A, have T, but we don't have distance. Do we have distance? No, we don't have distance. So there's no distance here. There's no distance there. So we choose the equation that does not have distance. And that equation is V is equal to U plus AT. Yes, if you look at it, there is no S. So it's going to be that V is 0, is equal to U that we're looking for, plus acceleration is minus. So it's going to be minus 9.8 times by 3. Do you understand? So it's going to be that 0 is equal to U minus, because plus minus is going to be minus. So 9 times 8 times 3. So it's going to be minus 29.4. Okay. So it means that for we to get U, this will move to the other side. It's going to be that 294 is equal to U. That is, our U is equal to 29.4 meters per second. So that is our initial velocity. Okay, so that's it. So let's take the next question. You see, from what height must an object fall freely to hit the ground in 5 seconds? So this is the height. This is the height. So assuming this is the ball and it falls freely. So anytime something falls freely, so we assume that it has been at rest. Once we see that something falls freely, we assume that it has been at rest before it starts falling free. So something that is at rest means that initial velocity is what? 0. Okay. So from what height? We are being asked the height. So we are being asked this height. Okay. So that is distance. We don't know it. So from what height must an object fall freely to hit the ground in 5? So time is equal to 5 seconds. So our acceleration is going to be 9.8. So if you look at our variables, which of the variables is not here? The final velocity is not here. I'm going to use the equation that does not contain final velocity. And you know, the only equation that does not contain the final velocity is S is equal to ut plus half a t squared. Okay, so what is our S? S is what we are looking for. The distance is what we are looking for. So that this equation is going to be equal to, what is our U? Our U is 0. So if we multiply 0 with this, so this one goes. So we now just have, so this goes. So the only thing left is half times 9.8. Then also multiply by t squared. T is 5. So we have 5 squared. So it means that our S will be equal to, so this divide this to give us 4.9. Then say 5 squared, 5 raised to power 2 is 5 times 5, which is 25. So 25 multiply this is going to give us 122.5. So, and that is height, which is meters. So that will be the final answer. Alright, so with that we come to an end of the class.